Hi folks, this is Calc 1 Quiz 19. We're given a region R bounded by y equals x cubed, y equals 8, and x equals 0. And we're asked to set up and not evaluate integrals that would find the following. So all of these involve revolving R about some line or some axis and finding the shell or finding the volume using the disk or shell method. So first things first, let's draw a nice picture of R. So y equals x cubed looks something like that. Y equals 8 is a horizontal line at 8. And x equals 0, well, that's another name for the y-axis. So you get R looks like this. That's y equals 8, y equals x cubed. And so this is the region R we're talking about. So in part A, we're asked to find the volume obtained by revolving R around the y-axis, and we're told to use the disk method. So we're spinning it around the y-axis. We're asked to use disks. So when you're using the disk method, you always want to chop up the axis that's parallel to the axis of rotation. So we're going to be chopping up here the y-axis. So we draw in one of our representative rectangles, which is going to make the representative disk. And we know that the volume of a disk is pi times the radius squared of the disk times the thickness. And the radius squared, remember, is the distance from the axis of rotation out to the edge of the disk. Since I'm chopping up the y-axis here, the thickness is going to be our delta y, which will become the dy. The radius then is I have to figure out some function of y. So if y equals x cubed, I need to know for a fixed y how far I go out. In other words, for a fixed y, what's the x coordinate? So I just solve this for x. X equals cube root y. And so I put this together. The volume by the disk method would be pi times the integral. I'm chopping the y-axis up from 0 to 8. The radius squared in terms of y is this thing squared times the thickness dy, or the integral pi times the integral from 0 to 8 y to the 2/3 power dy. We're just asked to set this up and not evaluate it, so that means we're done with part A. Okay, in part B now, we're asked to find the volume, once again revolved around the y-axis, but now we're asked to use the shell method. Okay, so for the disk method, you chop up the axis you're revolving around. For the shell method, you're going to chop up the other axis. So in this case, we're going to be chopping up the x-axis. So we're going to draw our representative rectangle in there. And remember, the volume of a shell is 2 pi times the average radius times height times thickness. And here average radius means the distance from the axis of revolution out to the edge of the shell. So in this case, I'm chopping up the x-axis, so the thickness is going to be the delta x, which will eventually become the dx. I need to know the bounds on the x. I know that y equals x cubed and y equals 8, so I need to look at where those things intersect. So if I look at y equals x cubed and y equals 8, I get x cubed equals 8, or x equals 2. So that tells me how far I'm going to be integrating. So the volume by the shell method is 2 pi. I'm chopping up the x-axis, so I'm going to be integrating x from 0 to 2. The average radius is the distance from the axis out to the edge of the shell. So if x equals 1, the distance from the y-axis is 1. If x equals 1.5, it's 1.5. If x equals 2, it's 2. So at any given point x, the distance to the y-axis is given by x. Now I need the height of the shell. And how do I get the height of the shell? It's the top curve minus the bottom curve. The top curve here is 8. The bottom curve here is x cubed. Times, of course, the thickness, which is now dx. And once again, that's all we're asked to do is set this up. If we were to evaluate this, we distribute the x through, use the power rule, fundamental theorem of calculus, and we're done. That'll do it for part B. All right, part C, we're now revolving r about the x-axis, and we're first asked to use the disk method. So I'm going to be chopping up the x-axis itself then, because it's disk method. And we know from before I'll be chopping it up from x equals 0 to x equals 2. Now I draw my representative rectangle in here. And I imagine whipping that around the x-axis. And I'm not going to get a disk. I'm going to get a disk with a hole in it because we're going to have this gap. Not gab, gap. And that gap is what's going to generate the hole. And so most textbooks call this the washer, but I like to think of it as a disk with a hole in it. And so the way we handled this in our class is we extend this rectangle all the way down to the axis of revolution to give us an honest-to-goodness disk again. So we're starting at y equals 8, and we're going to extend everything down to the axis of revolution. And by doing that, we're going to get honest-to-goodness disks. Now, if you whip this around, it's a rectangle. You're going to get a cylinder out of that. You can find that answer geometrically. But remember, to get an honest-to-goodness disk, you have to have the base of the disk resting on the axis of revolution. So this would give us what we call the hole volume. And now we have to subtract off what the gap gives us. Okay, so the gap is generated between the curve y equals x cubed and the x-axis. And once again, if I draw the rectangle down to the axis of revolution, I'm going to get an honest-to-goodness disk. This is what we call the hole volume. So it's the hole minus the hole. And once again, the volume of a disk, remember the basic formula, pi times the radius squared times the thickness. So we're going to get pi times the integral from 0 to 2. The height, or excuse me, the radius from the axis of revolution out to this line is exactly 8. So it's 8 squared times the thickness, dx, minus pi times the integral from 0 to 2. The radius from the axis of revolution out to this curve. This is y equals x cubed. So we square that times the thickness dx. So that's pi times the integral from 0 to 2, 64 dx, minus pi times the integral to 2, x to the 6th dx. You go through your fundamental theorem of calculus. All we're asked to do is set things up, so that's exactly what we did. That'll do it for part C. Alright, part D, we're asked to find the volume revolving once again around the x-axis, but now we're asked to use the shell method. Okay, so since we're using the shell method, we don't chop up the axis parallel to the revolution. We chop up the other one, so in this case we're chopping up the y-axis. So I'm going to draw one of my representative shells in there. And if I whip it around, I get my standard shell. Now the thing about the shells that's kind of nice is that the shell has the holes built into them. And so remember the volume of a shell is 2 pi times the average radius times the height times the thickness. Okay, so in this case I'm chopping up the y's, so my volume is going to go 2 pi integral from 0 to 8. What's the average radius? The average radius is the distance from the axis of revolution, namely the x-axis, out to a particular shell. Alright, now I've chopped up the y-axis, so for a point on the y-axis, how far are you to the x-axis? Well, if I'm at y equals 1, I'm 1 unit away. If I'm at y equals 2, I'm 2 units away. If I'm at a certain y value y, I'm y units away. That's my average radius. Now I need the height of the shell. The height of the shell for a given y. For a given y, how far out do I go to this curve? Well, I need to solve this curve for x, which we've done before. That's the cube root of y. So that's the cube root of y. And then the thickness is the dy. So if I simplify this integral a little bit, it's the integral from 0 to 8, y to the 4/3 power dy. So that'll do it for part D.